So goals for today, what and why to digitize? Because there are some things that are harder and some things that are not as hard. So I've actually been thinking a lot about the project that we're doing. So like the Kanagawa waves, I did not know they were like open, like they're not copyright. You can do anything you want with the Kanagawa waves. So that's a wood print from Japan. Like if you think of waves in Japan and then something comes in your head, you're thinking the right one. And I can show you something that was done by Sketchfab where he just took a dimensionalization tool that they have. I don't think it's as detailed as what we're thinking, but how to digitize, so choosing the right path to 3D. 3D digitization technology is available at IU in particular. So 3D software modeling, which will be Jeff, hardware-based volumetric modeling, Jeff, hardware-based surface scanning, Jeff, and then software-based photogrammetry, me, and then I'll talk a little bit about post-processing workflows. And then finally, 3D digitization in a broader context, like what a comprehensive workflow akin to something like MDPI, which is the Media Digitization Preservation Initiative, which if you listen to NPR at all, they've been, I think they're advertising during Marketplace right now, and they tout MDPI in it, which has been interesting. Results and applications, and then sort of conclusions and how to apply 3D digitization to your work. So, what are the things you want to do? Well, so common application areas include cultural heritage, natural history, architecture and design, art and creative activities, engineering, medicine and anatomy, and GIS and archaeology. This is one of the more famous ones. This is where they recreated a mandible for a gentleman who had it eaten away by cancer. This is from Cody Warner's Places and Spaces. Took a fair amount of hand modeling to create this one. This is Monte Alban in Mexico, where a drone was flown over the site and then interest points were added, and it was stitched on our HPC system in about 30 hours as opposed to weeks, which is what it would take on a beefy desktop. Here you can see multiple collections. I think these are antelope skulls, and you can use them for students to sort of identify the differences, right, as you've got all of these skulls across the way. This is a sounding trench from a site in Italy where obviously as you dig things up, you're never going to replace that, right? So you're losing information and data and whatever, and that's sort of, we know that as part of archaeology. But here they took photos each of the ways down so you can see what that excavation process looks like. So I really love this one. And then Katie did, this is a Book of Common Prayer from 1604. That has a hand embroidered spine, which I absolutely like. I embroidered stuff like that. That is at the lily. And so it's this thing that's really fragile, is not out very much, and they asked her to digitize it. And then finally, this clarinet mouthpiece is an example of parametric scanning. It had made its way out of Nazi Germany. It evidently had a really unique sound, and the person who made it gave it to one of the professors here. But of course, if we just scan the surface, that doesn't mean anything. So what you have to capture is the structure of the mouth. So why? Digital preservation, obviously things degrade. I just turn myself off. Oh, I fell off. Let's see, I'm too excited. Even when I'm sick, I'm excited. So coral reefs are something that are being documented a lot right now because we know dieback is happening in oceans. And documentation, like I said, again, with these like archaeological expeditions. So rare and valuable, delicate collections that may be changing by accident or by nature. Time-varying structures and sites, or supplementing physical preservation that's going on. They enable novel research or creativity, so you can acquire and analyze geometric or spatial data in a way you couldn't before. I also like the idea of you may never have like all of the Van Goghs, right, in the same physical space, but you could have them in the same virtual space. Or someone who's probably a famous sculptor might be a better example of that. So, so if you're sort of just thinking about like something that would never, it would be too expensive, too costly, the insurance would be crazy, like some places would never let it go. And now you can do this virtually, which would be really cool. And then also creativity, creative activities and artistic interpretation. So we've been working with Melanie Pennington and her students who have been making these humanimals. My favorite is this crow person out of clay, and then they are capturing them with photogrammetry, taking them into a product called Rhino, and then deforming them even more, and then 3D printing them. So yeah, easier access and broader dissemination. So again, if you're not here, but we have all these amazing bones of one thing, like we have dire wolves, because dire wolves are native to Indiana, they are real, they don't just exist in Game of Thrones, then this is a way to access it without actually making the trip to Indiana, which is not always available to some scholars. Teaching and learning, if you make a 3D print of something, or even having it online where you can spin it around, you're now providing access in ways that are probably more compelling and giving you more information for the students. And then community engagement. How do you make these collections where, I mean, only 5% of any given museum collection is usually on show at any one time. So the rest is in storage. And I just learned that like some of the things that are from the Eskenazi that they're gonna be putting into the ALF, which is the auxiliary library facility, are going to cold storage. So that means like you freeze it, right? So there's no bugs in there, which means if you were to take it out after to digitize, right? Like you really have to have a good reason then to get it out of cold storage. So really thinking about what that means. So this happened not too far in front of our first talk. You're probably familiar with the big fire that happened in Brazil that took out something like 85% of their collection. And it was devastating. And it was something like less than 8% even existed as photos like this. They made a worldwide appeal. If you had ever taken a photo inside the museum, if you had digitized anything, I think like 25 objects went up on Sketchfab that people had done, but they lost everything. Also, the Palmyra Arch, which we can have a long debate about one company that did reconstruct it inaccurately and then tried to copyright it. And there's an article in our online digital heritage journal here about it. But so ISIS obviously did a fair amount of destruction in their heyday, as have the Taliban and others. And so this is a way of preservation because the world is not perfect. Okay, but now you're like, I want to do this. How do I do it? And now I'm going to hand it over to Jeff.
Take over. Okay. Can I be heard? Am I heard? Sorry about my voice. Jeez, I can't carry it like you. I'll end up turning it off. All right, so on the how, we choose between different techniques when we're going to digitize an item. And you can see we've created this workflow or this flow chart. And the thing to take home on this flow chart is no matter what method you use for digitizing your objects, your post-processing phase will always work for all the digitization methods, with the exception of the first one here, which is our first question is, do we digitize an object? And so, I don't even remember our presentation, what order it is. There we go. So this would be an example of an object, sorry. This would be an example of an object that you would never digitize. This is something very simple to just take a pair of calipers to it and to measure this object. What do you have? You got a couple cylinders. In this case, I didn't even use cylinders. I created the profile. This client did want to scan this object because he wanted to change it on his microscope. But in this case, it was much easier for me to take a pair of calipers, get its profile, and then revolve that profile. And then he could punch into the software any dimension he wants on that profile, and it will update the 3D object. I did this in 30 minutes. If I was to go through photogrammetry or even scanning, it would take me hours to get this type of data set done. So it's not a substitution for 3D modeling, which a lot of people think digitization is. But let's say you have something that is where you need to capture the interior data of the object, such as bone material or the clarinet mouthpiece that Tassie talked about earlier. That's when you would want to use volumetric scanning techniques such as CT or MRI. And we do have the workflows for post-processing that data, but we don't actually capture the data for you. That would be something like you would go to the School of Medicine, and we've done that in the past, and they've captured volumetric data. And then the last, whoops. Oh, I guess I'm talking about it here. So some examples of where we've done volumetric data, our workflows have helped. Everything from the surgical guide that you see up there for making a more accurate shoulder replacement surgery, the unique clarinet mouthpiece Tassie described, and then our most exciting one that we've done recently is improving the radiation bolus up at the radiation oncology up in Indianapolis. So the reason we're excited about this, we're working with a radiation therapist, Brian Obershiner, and he came to us and said, I want to improve how radiation bolus therapy is utilized. For those that don't know what a radiation bolus is, it's basically artificial skin that they place over your skin so that they can better target radiation beams to tumors that may be close to the surface of your skin, so they can increase the dosage and it won't burn your skin. They've been using this kind of flexy, very expensive medical plasticine, if you will. And as you can see, it does not form fit to the head. So what Brian wanted to do was use the CT data they already have on the patient anyway. They already have the bolus data as well from the dosimetrist, and he just wanted to extract that and print it so it would be perfect. So he's printing molds. You can see a mold for this gentleman's skull. That was his first case, and it fit much better on his skull than the one that has all the air gaps where he was basically duct taping it to the patient. He's done a lot since then. I think he's had 50 patients that he's worked with, and he's got some software in-house, but he started with our workflow, so we were very proud of that effort. Now the question is, and this is always the harder one for us to answer, do you photogrammetrize the object or do you scan it? It's actually easy for Tassie and I to answer that question because we know it most of the time. Where it gets hard is people learn one technology and they don't want to let go of that technology. For 3D scanning, our general rule is if it's something you have to have very quickly and you need to have accurate scale, then 3D scanning may be advantageous for you over photogrammetry. Those scenarios apply to the medical applications. So if we have a prosthodontics or if we're doing something for radiation bolus, he scans the patient and he has that data instantly that he can start working with it. So time is of the essence because of the medicine involved. Engineers, they want to scan an engine manifold. They don't care about color. They just come in, they scan their engine manifolds, they scan the front of their cars up at Purdue at IUPUI, and then they redesign the front of the car and try to make it go through the air faster. We helped them have a better race season last year. I don't know if that's true, but I'm going to claim it anyway. Where you don't want to use scanning is when you're doing cultural heritage and you're trying to capture high detail color, and we'll show you that later on. It used to be 3-4 years ago, scanning was probably better because photogrammetry was so slow, we didn't have workflows in place. But with the advancements of supercomputing infrastructures here at IU and the advancements of the software and the workflows, photogrammetry is better for cultural heritage. But if you are using 3D surface scanning, here are some options that are available to you. The one on the left there, the Leica LiDAR is actually not one that we run, but we work with a company out of Lebanon that will use that system. You pay them, I think, $1,500 a day. The Matterport system is something that we do support. It's a combination of 3D scanning and 360 image capture. And then those systems, the Next Engine and Minolta, we don't really support those anymore. The GoScan system is the one that is our premier scanning system. It's probably the one people have seen at the libraries as well. And then the 3DMD is a system that we used for this project, which was the collaborative initiative for fetal alcohol spectrum disorders. In this case, speed was of the essence. We would line up 200 kids and we needed to capture ear-to-ear data. The 3DMD system would capture the data instantaneously like flash photography, and then it took the laptop about 20 seconds to produce the actual 3D data. So we captured over 5,000 subjects over a 15-year research project with that particular system. We still are using it. up in Indianapolis for the radiation bolus therapy now. Here are some example projects where scanning was a better solution. In this case, there was a surgical simulator that Brian Overshiner, the same guy did the bolus, down here at the shoulder. He wanted to redesign and print his own shoulders to train surgeons how to get into the bones because I guess they're very expensive. And if you look, this training device already has the holes predetermined. It's almost like surgery by numbers. So he wanted to print ones that didn't have the holes so they could actually grade the surgeons. There's the prosthodontics work we did with Travis Bellici. The blue part you see there, a cyan colored part, that's actually an engine push rod. That was an engineering student in Indianapolis whose father happened to own a racing team, and the engine part kept breaking. So he was scanning it and trying to analyze where it was bending and breaking in the middle of races. And then the one on top there is a swim trainer, again, an engineering project. The one on the right, bottom right, the augmented reality, I think if I had the choice now, I'd probably photogrammetrize that data set. This is the LiDAR example that was led by Zeb Wood and Albert Wayne up in Indianapolis. So they hired this company, Online Resources, out in Lebanon, Indiana, to come out. They LiDAR scanned the Bethel Church. For those that don't know, the Bethel Church was the oldest African-American church in Indiana, and they are turning it into a hotel. I really don't know what they're doing with it, but they're shutting it down. So they want to do a cultural heritage and capture it. Everything you see on the right two images, those are hand models. So they use the LiDAR data as a reference, and then Zeb's students rebuilt the church by capturing photos and putting their own materials in, but that's all hand modeling on the right. And there is a VR experiment there, or experience for that as well. So I'll talk a little bit about the limitations of scanning. These limitations also apply to volumetric capture, and they also apply to photogrammetry. And the one that is most confusing for people is accuracy versus resolution. So accuracy is the certainty at the point of measurement. I always said error. I guess I'm a glass half empty guy instead of glass half full. And I'm representing that on this bottom left image by these little spheres. And then the resolution is the distance between those points of measurement. One common misconception people have when they do volumetric data or surface scanning is they crank the resolution up as high as they possibly can, thinking they're going to get a more accurate data set. That is not true. If you look at this cube on the right, for me to actually get accurate data, I only need a few samplings of the surface of that cube. Now, I would never scan a cube, but let's say I did. If I increase the resolution, then the surface of the cube starts looking sandy because every one of those points of error ends up being that little sphere, and it ends up being these little sandy dots. The same thing happens in photogrammetry. When we crank it up really high, it tries to get more accurate, but you have more points of error as well. So keep that in mind if you go down any type of digitization path, that high resolution does not necessarily mean high accuracy. Our scanners do capture color. This is the photo that took us forever to actually line them up. I don't know why. But as you can see on the left, the color that you acquire from a scanner is nowhere near the quality of the color that you get from photogrammetry. One thing I don't think we put in here either is our scanners don't capture as much detail as photogrammetry does as well. You can, this is relative to the resolution I was talking about earlier, but we have been, with our modern workflows, we are able to get into crevices way easier than a scanner can. Just from 2D photography. I don't think we have those examples here. So now I've talked about how, do you digitize, do you use volumetric, or do you use surface scanning? And now that you've seen the quality of the color, I hand it back over to Tassie. And you can cover post-processing.
Thanks. It's okay, I broke it. So now we've hit the point where we're like, photogrammetry, and you've decided you're gonna do this. And so we should talk about some of the different methods involved. So it's a method for extracting three-dimensional data or models from an object, environment, or terrain from a standard set of two-dimensional photographs. It's actually been around as long as modern photography has. They used it in World War II to find camouflage tanks by seeing the difference in elevation where those tanks were. Because you would take one 2D picture and you just be like, I don't see anything. And then you compare two and you start extracting elevation, you're like, there's something under there. It's applicable to a broad range of academic disciplines, including cultural heritage, architecture, paleontology, and geospatial stuff. And it results in high computational complexity and large data sizes. So we talked about the fact that a couple of years ago, the scanning was going to happen a lot more quickly, and so it seemed like an easier route to take than photogrammetry. And that's partly because, and I think this is next. Oh, we're going to hit it in a minute. The math is a little complicated. What we've got here that's really cool is we have 100 licenses for Photoscan, which is a photogrammetric software, running on our HPC clusters here. And you would wait in the queue a really long time to actually get 100 nodes, but you can use 8 or 10 of them. So that think about, instead of having one desktop, even if it's a beefy one chugging away, you've now got 10 splitting all of the digitization into pieces and doing a part and then bringing it back together at the end. And so it cuts down that processing time sort of exponentially. So here's our friend Ernie Pyle sitting out in front of the New Media School, post correction on his side little patch arm. We took 300 plus photographs capturing all angles and details. I actually want to go back and get into, I think we've got the typewriter pretty good now, but I think we could do a little bit better job with the typewriter. Which is actually kind of a challenge because it's keys with like all this deep space in between them. So we do the photogrammetry and 3D processing, and then at the end we get a texture mapped 3D model. So photogrammetry supports many types of cameras and rigs. We use a DSLR camera for ours, but you can actually do this with a classroom set of like smartphones or whatever. There are also these little cameras called Ricoh Thetas, and supposedly you make stitches out of 360s. That's something we're still playing with. And then you might be familiar, of course, with drones. Because people talk about drones all the time. That's what the multi-Alban site was done with, right? So you can get to things that you couldn't normally get to, even with scaffolding or whatever. So this example right here is, these are pictures being taken of a pot. We've got lighting. This is a light tent to sort of isolate the background. It's on this etherfoam. We were supervised by museum folks at the time to make sure this, I think this is a pre-Columbian pot. It's very old. And they even built us a cutout so we could flip it over so we can do the bottom and the top. And then we would take these photos at these different heights and in the round. This is a photogrammetry rig, which we do not have, but which people often ask, can I model myself? And I would need something like this because you move too much. So it's really important that your captures are as still as possible. I was really surprised that she came out as well as she did, because the day that I captured her, the bus was going around. Like I was trying to keep the bus like out of the background, but yeah. So ideally, it would be on a cloudy day when there are not a lot of people walking around her and the bus is not circling the Fine Arts Plaza. So this is actually where you can see that in the round. Every blue square here represents a camera capture, and where it's extrapolated back to where it thinks that that camera is. So this is a bust of Lincoln that's in the Lilly Library. It's famous because it was done by Borglum, who is also the person who did Mount Rushmore, depending on how you feel about carving things on Native people's lands of white men. You can tell how I feel about it. So yeah, you can see we did a lot of captures down here. And you can see here where we're also just trying to make sure that we have about 60% overlap as we do it. So these are some of the things that we have done with both photogrammetry and with scanning. We need to get the blood bowl like out of there, correct? Yeah, I love this. We scan this. This is a bleeding bowl from the end of the 19th century when they believed to make you better. Clearly, Jeff and I need to go do this. They would let blood from your arm, and then you would put your arm over the bowl to catch the blood. Yeah, absolutely. It would cleanse us, which is not how that works, but that's okay. This is, so there's the Ruth Lilly Medical Library had a loaner collection from someone, and there was all this really cool turn of the century medical equipment. Those of you who don't know, I didn't know before I started this, this is the old oaken bucket, which goes between IU and Purdue, depending on who wins the football game, the head-to-head football game every year. The very first year they played, this IMP means that they tied, and they tied 0-0, which I thought was really kind of sweet. It is from an actual Indiana farmhouse where it was used as a well bucket. They've had to reinforce the bottom. Jeff and Tyler spent a long time stringing these up in the right order. I do think we should make the eyes all red, although that might highlight. So that might highlight, so there is a huge disparity between the number of P's and the number of I's. And then here's Herman B. Wells sitting on his bench. And what was really cool about this is a bench doesn't capture very well because of that negative space here. And so Tyler, who's one of the people we work with, went ahead and modeled that for us and then applied a metallic texture that matches Herman quite well. I would also love to do, I didn't realize there was an inscription on the bottom rim of the hat. So I think we need to add a little, you can, in Sketchfab, you can add annotations. And so I want to add an annotation. So this is the math I was talking about. I should put this for, so why HPC? Why not just buy like a beefy desktop, which is like gaming computer on up? So what we've seen people spend is like $5,000 on a desktop. Well, one, that desktop is then taken up with whatever you're processing pretty much all the time. So to do like Herman Wells takes about 8 hours on a desktop. So this way you can sort of set it and go, because this is happening remotely. Use your computer for whatever you were using your computer for. This is the math that is happening to do all the calculations to create that model. So you can also do some things that you cannot do at all with a scanner. So this is the interior of Saint-Chapelle in France, Paris, France. And these are all taken sort of, he was situated on the ground, but he took these in the round. Even though it was a really crowded day, it was sort of a proof of concept, and it came out really well. This is the Rose Chapel, and this was done with drone flyover. And then here again is Monte Alban. So this is also some of the larger collections that have been done. This is another one where we've got collection of femurs here. And so I guess you can sort of compare these different femurs and what's going on with each of them. The IU Virtual World Heritage Laboratory on campus with Bernie Fisher and Matt Brennan. This is a boxer. And so you can see how his hands are wrapped here. Like, you know, so they, even back in the day, right? Like you wrap your hands before you do this thing. And then again, here's the COSA's archaeological sounding trench. And so Matt would fly the drone at the end of every week, I think is what he decided was a good time period. So here is our processing stages. So initially we went out there, right? And we took all these pictures in the round. And so the first thing you do in this, or the system does, is it aligns the photos. Like I said, sometimes if you go in and you turn this mode on, you'll see a camera that's way off somewhere, and it's just, it got confused. It's that error that Jeff was talking about, and you can toss those cameras out so that they're not part of the final model. And it generates a point cloud, and if you've done a good job, you're like, here you can see his little coffee cup. You can see his hand, you can see his goggles on top of his helmet. Like, so even though this is just created from points, this is probably going to work out just fine. And that's actually a really good check, because this is much faster than doing the completed model. If this looks like garbage, your final result's going to look like garbage. This is the mesh. So believe it or not, it might be really hard to see on the inset here. This is made up of millions of tiny triangles. It's called a polygonal mesh. This is what we would call sort of the raw output. This is not something we would put on the web. So we're actually sitting down to talk about like what the right size for web distribution is. And then maybe if it is an open source thing. Like for us, this is something that IU has said that people can download it. It's fine as long as they don't sell it right on. So we'll put a Creative Commons license on it. They can download the archival package if they want all million polygons. And really above about 1 million polygons, things that you do post-processing software will start crashing because you're not going to have enough memory on your machine to be able to do it. And then finally, it does what I like to call the SRAM wrap stage, in that it takes the JPEGs, right? It takes the pictures that you took, and they've been flattened out into one single JPEG, and it wraps them over the mesh, and then they all line up, and you get Ernie. So it's kind of amazing. We should have a picture of an unwrapped. So photogrammetry software, again here we support Photoscan by Agisoft. They've been around for a fair bit now. They are run, it's a Russian company. I think they've now got 4 employees. They used to only have 2, but I've seen other people on the forum, so they're growing a little bit. Reality capture by capturing reality is, I can't remember, it's another Eastern Europe, it's a Eastern European country. They've only been around for 3 years. Their subscription method is you can get an unlimited license forever for 15,000 euros. But that's a lot of money, and it includes a 25, that doesn't include a 25% per year maintenance fee. You can get a yearly license for 7,500 euros, and then you still have to pay a 25% maintenance fee. Or, and this is what a lot of the people doing like commercial photogrammetry, like I need to sell my Nikes on Amazon, is you can, on Steam, you can purchase a 3-month 99 euro or dollar thing, and it's got some restrictions on it. And so that's what a lot of them are doing. And the reason they're using it is because it had been faster than Agisoft, but they are renaming this now Metashape because we couldn't possibly make things easy. And Metashape seems to have sped up their algorithm, and we're in testing right now where, and they've just upgraded our licenses as we want them. So we have 20 of our 100 pool are now Metashape, and we're playing with them. Their support is really great. They're really awesome. 3D Zephyr by 3D Flow is supposed to be good. It only works on Windows machines. So I have not spent a lot of time on it because all of our HPC systems are Linux. And that's the other thing. The only thing that's Linux compatible on here, right here, is Photoscan. Reality capture is also Windows only. Autodesk has gone through recap, remake, and now in the course of the 4 years I've been doing this. So one of my favorite things when I was doing phone capture was they used to have a phone app, and then it would push it off to the cloud, and they've discontinued it. And they are now Windows only. So we're working with some open source workflows here. You can see that there's MVE, OpenMVS, OpenMVG, Visual SFM, and a couple of other things. What each of these needs is that you pick, there's a pipeline here, and you need a fair amount of command line knowledge to actually string them all together. We're working on doing that for you, and when we get to the point where that's deployable, we're hoping to put that on a national high performance system called Stampede and Exceed, and that means that basically anyone in the US can use this, which I would be super excited by. Because I would love to see like a tribal college that doesn't have any money, just be able to go. And I'd love to see them digitize their own stuff, right? Because they don't need me handling objects that to them have significant worth, right? So comparing the options, we just threw a lot of stuff at you. The pros of surface scanning are greater spatial accuracy down to 1/10 of a millimeter. There are some measurement devices out for Photoscan so that you can improve your accuracy, but it's not going to be as good. Less time on site. So one of the things is when you scan, I think the other thing is, so Jeff was saying like you get instant feedback. So you have the scanner in your hand, and then there's a laptop. And so literally like as I'm scanning, it's showing it up right here. And so there's a flash, right? Whiz bang being like, oh yeah. And you're not going to get that with photogrammetry. But you saw that like that owl, it actually has gouges in it, and that wasn't really visible on that slide. Cons, expensive. So the scanner that's on there is $25K, the educational rate of 2 for $30, $35 now. But that's assuming you've got a chunk of change to spend, right? And now, oh yes, and then customs in Canada, and I don't know. And yeah, you have to upgrade equipment to achieve future gains. Photogrammetry, sure, a good DSLR camera might run you $2,000 to $3,000, because you really do want to. I actually did her with my $400 camera, but again, I think she's a fluke of nature. For all the really good ones, we've been using this more expensive camera, and it's amazing the detail, the quality that comes out. I think her size is why this happened. So $2,000 is not 25, right? And then you just need a good tripod and some other stuff, but you can really get rolling for like under $4,000. And that's important. So drones have also come down, and we actually have added underwater. So I don't know how many of you are familiar with the Thomas Kidd wreck that Charlie Beaker here in the Underwater Science Department did, and they did it with photogrammetry. So I can't imagine sometimes I mess up plain air photogrammetry, what it would be like to swim and scuba and get these results, but it's really cool. And it's better for color capture. There's the potential to reprocess it, right, for greater accuracy. Like since we've really noticed that the software has been improving by leaps and bounds in the last couple of years. And I wouldn't be surprised if like 5 years from now, I want to reprocess all my photos, which is why we take them all in RAW. And then the potential for more detail capture, and then scalable, like we talked about. Cons, lower spatial accuracy. So this lengthy, computationally expensive post-processing, which is getting faster. There are challenges of processing in the field. So that is the one place where, so Monte Alban, guess what? There's no electricity there. And we've actually had this come up more times than I would have expected, where the internet is an issue. And I was like, oh, like, you know, you kind of think like the whole world's connected, except for maybe sub-Saharan Africa. And so not true. The Uffizi, which is where Bernie Fisher's group has been working, actually they've been doing a lot of work in their offsite storage, which is this crumbling Italian villa. And there's no internet there. So, I mean, they can go back to their hotel at the end of the day, but then they have to send like fairly large photo sets, right, to our system to be able to begin stitching it. Whereas when I was in Brooklyn at the Brooklyn Museum of Art, I was able to upload stuff from the museum and actually have it stitched while we went to dinner, which was cool. And then there's the potential inadequacy or failure of a photo set. My current bugbear is this Rita Hayworth makeup case at the Lily, which I both love and despise because it has these glass bottles, and I thought they were maybe like they weren't shiny enough that they would be a problem, and I don't know why I thought that because it's totally not true. So glass is bad because the angle of reflection changes every time you move the camera. But it's like, oh, but there's perfume residue in there. It's not really that shiny. And I'm like, no, it's not true. So luckily the Lily's right here. And so we've now shot that box, I've been saying 3 times, says Katie. So we're there. So we've obviously had time to learn from this. There is a learning curve. I would compare it if you're a skier or a snowboarder. On skis, on the first day, you just go like this, and you make it down the hill. On a snowboard, guess what you spend your first day doing? Falling down. And it's really, but by day 3, magic happens. And then volumetric scanning, the pros are you capture these internal structures. So those bones, they were studying songbirds and how they make sound in their head, which is why you had that sort of bird-like picture on the slide. Very high resolution. Cons, we have to rent the CT scanner at the moment from the hospital, correct? So it's like $250 an hour, maybe? So maybe if it's a really important thing, sure, but not like, and it's cumbersome. Some of the materials are gonna cause noise. There are size limitations again. and the object must be brought to the scanner, which again, I can point to folks with like really expensive things and you're like, no way, right? Like already like you standing there watching me digitize something costs money, let alone me saying, I'm gonna like make this leave the museum. So there's that. So finally, there's metadata, archiving, and dissemination. And I'm gonna kind of gloss over some of, actually, I'll talk a little bit about it. Metadata is a wild west right now. I am part of a group that is discussing these kinds of things and nobody can really agree like exactly what to capture. So again, give us a little while. There are best practices recommendations and we're going with like good, better, best. Archiving, I recommend for my stuff, archiving the raw, archiving the derived JPEG where they've all been white balanced, archiving the initial stitch, archiving the post-processing done to make that watertight and put up on Sketchfab, and archiving the web deliverable version, which means you need to have a lot of space. And that's not, we don't actually have a checksum repository here that makes sure that there's no bit corruption, bit and byte perp. So that's actually, I can put it on tape. I can push it to SDA on tape, but there are lots of places that don't even have that. And dissemination at the moment, Sketchfab is what everybody talks about, but it's kind of like putting all your videos on YouTube and then being mad if like Google decides to close YouTube tomorrow. So you have to keep all that stuff. There are some independent players coming out. And again, I really think this landscape's gonna change in the next year or two. So at least you can host it institutionally. So these are some of the post-processing techniques. And I'm gonna let you talk about it, even though.
Are you really?
No, I'm right, fine, fine. He did that, he's like. So polygonal decimation. So this is something we're actually talking about. Different programs do this with different levels of success. Because sometimes we decimate and the thing comes out worse than we expected it to for the level of detail that we're decimating at. So we're actually making some decisions about that right now. And the reason this is important, beyond the million, like this is only 360K polygons, and now 79K, but we're hoping that it's because we do want, generally, if you're loading this on a phone to show to somebody, we want it to be mobile loadable. And 360K is probably too big. And then here you're gonna heal holes. So this elephant had this little problem. This was occluded, didn't get filled. And so Jeff just went in and filled it. And that's important if we're gonna 3D print it. You can't 3D print anything that's not watertight. So people talk about watertight, watertight. So there are some things you may never print. There's this beautiful gold dress that Caroline Harrison wore, the wife of Benjamin Harrison. And it had lace things and like, that's never gonna be watertight, and that's fine. But something like this, you're gonna want it to be watertight. Here's the healed mesh on this. Here's the project source color, and then here's the color preservation. And so often you're gonna wanna do the healing, and then when you're done, you can see how this looks terrible now, right? So you have to reproject that UV map. You have to reproject the texture. This is you, man. This is all chunky stone. I don't know chunky stones. I'm not from here.
2 slides. All right, so I'll talk a little bit about the parameterization here, because Tassie evidently is afraid of talking about this. Excuse me. So parameterization of a model is when you're extracting the parameters that mathematically define geometric objects. So when we scan, digitize, or when we do any digitization, what we end up getting is points and polygons. And those points and polygons are not smart, they're dumb. They're just points and polygons in space. We can look at these points and polygons on this image on the right, and we know it's a sphere because we're humans. We're smart enough to figure that out. But the computer system does not see it as a sphere. So we parameterize it and turn it into an actual sphere with a center in space and a radius to it. And the example I did recently is a chunky stone. And for those that don't know what a chunky stone is, it's a, it was a game, as I understand it, that Native Americans played where they would roll this stone into a courtyard and the competitors would throw spears at it or shoot arrows at it, and whoever got closest to it or knocked it down would win the game.
It's like bocce ball, but with spears.
Yeah. And the chunky stones come in a lot of different sizes. If you look it up, you'll see images of them as tall as a man. I think they're made out of wood, all the way down to this one, which was a few inches across. I became enthralled with it after talking to the anthropologist up in Indianapolis, and I wanted to play chunky stone. So I scanned the one that he had from his collection he got down in Illinois, and then I went through the process of parameterizing it. And a couple of things you'll notice about parameterizing. I basically took the scan, I took the cross-section of the best cross-section, that's subjective on my part, of the scan, and then I just took the quarter of that best cross-section, and then I duplicated that quarter by mirroring it twice, so that I would have that same quarter cross-section being identical, and then I simply revolved it. And then you see on step 7, I can actually do a deviation map on how close my parameterized data set is to the original. So mine is, I'm going to use the word perfect. It's not, you know, it's perfected, but I'm not belittling the work that the Native Americans did. Green means I'm within, I think, 0.01 millimeters, and then red is where it's the original is lower, and then when you go blue, that's when mine is higher than the original. Yeah. So I don't think we brought it though, did we? No.
I don't have one.
It's a blast. It's fun to play. I suck at it, but it's fun. That's it. I think that's it. You had me come up here for one slide.
Oh my gosh, I'm so mean.
Yeah, this is you.
Aw, man. We should definitely bring chunky stones for, and then like, especially now that it's spring, we should have brought it for this one. It stays perfect, right? You go outside and get in trouble throwing spears on campus. This is actually something that we, that Eric, our boss, adapted from the IU MDPI workflow. And they've got all of these different sort of swim streams that you need to think about. So you have your collections, right? So you've got physical artifacts and objects, rooms, buildings, and terrains, and then you have object records and metadata, right? Sort of all feeding into what you're going to do. Really, Mr. Mike? Well, Mike knows more than like I do. It's like, done. We want to go play Chunky Stone. Stay. Okay. So then pre-digitization, you need to think about a couple of things. So often you're going to have to prioritize what you want to capture. So I've been talking to some folks at the Smithsonian, and if you think about all 9 now, I think, Smithsonian museums, they have more requests than they can handle, and so they have to prioritize what gets captured, both by what their ability to capture is, but also sort of what the most compelling objects are, or if it's really fragile. Rights management is another one, and this is something that, you know, there's people working on copyright on this. There isn't a lot of case law, but again, that CS3DP has a whole copyright group, and I have some documents I can share if anyone needs that. Then there's the physical asset tracking. So with the Smithsonian, all of their 3D digitization is actually, it's done in-house, but it's a separate building than where the other museums are. They very rarely go to where the object resides because they have setups that are done, because their setups are pretty static. Or you could transport equipment to the site. So then there's the image and data acquisition. So all the things we've been talking about here, all these different methodologies. Processing, so photogrammetry is called structure from motion. There's the meshing and texturing. And sometimes there's a multi-source scan merger, which is actually what we did with that Purdue Oaken bucket. We're having a really hard time with the chain and even the bucket itself just really coming out well until we merged the scan data with the photogrammetry texture. But that's not something you're going to want to do on everything. And And then for post-processing, you're going to have that editing. You may have format conversion. So most of the things that are being spit out right now from our photogrammetry software, so it creates a .psx, which is the proprietary format, but it also creates an OBJ, which is still technically proprietary, but seems to be what most folks in the industry are using at the moment. So with the scanner, it creates a .vfx file, and then an OBJ with sidecar files. One is a .mtl, which talks about the material specularity and stuff, and then that JPEG that is like the saran wrap that I talked about, which is part of the reason you need to have a player that can handle these sidecar files. It's a little bit weird for a lot of traditional databases. It's not like an all-in-one. You can bake in stuff, but then you lose the ability to manipulate it ever later. And then you want to do quality control. I just recently discovered that Hoagie is sitting on a piano bench that has a hole on it. You can't see it here. Oh, because Hoagie's not here because A, Eric broke him, and B, his piano bench broke, or his piano leg broke. But his bench, I hadn't ever really looked at it large. And then I saw it on this wall, and there's this huge gaping hole. And yeah, so we need to fix that, obviously. So there's other kinds of quality control. We noticed that when we first captured Lincoln, we ran it through those two different softwares. There was some light on his nose, and so it gave him a nose job, which is not okay, right? And reality capture gave him much more of a nose job than Photoscan did. So that was interesting to note in terms of just, yeah, like in these comparisons and making sure it's right. Metadata creation, you do want to at least track like the camera and the operator and the lens and just those kinds of things, whether or not you choose to expose them right away. So you have them for later. And there's some folks at a place called Chi in San Francisco that have this digital lab notebook that they've been using. And then finally, this archival package creation and deposit, where like I would put all the things together and at least put them on SDA, so I know they're somewhere, right? And then over time, I might check them back out and make sure they open. That would be a good thing. And then discovery and access. So what do the catalog records look like? How are people searching for these things? Like right now in IUCAT, you can search for realia, which is what an object is, right? It should pull up all the objects. But not everything that is an object in IUCAT is tagged with the word realia. And so you actually don't find everything. The Slocum puzzle collection, because it's endowed by Jerry Slocum, is actually really well cataloged, and you'll get all of those. But there's other things that I know we own, I know that are cataloged, and you have to search for them other ways. So you really want to think about this ahead of time. We're currently creating a display in Omeka for people to see. We can talk about that some, like, you know, what does access look like? Who's your audience? And finally, what does a 3D specific search look like? I mean, does 3D become something that now we ask IUCAT to have as a facet? And then presentation and analysis. So virtual reality is an option. Everything that's in Sketchfab has a little Google Cardboard icon, and you can click it and then stick your phone in a Google Cardboard, and you can see that thing in the cardboard. It's a little crude, but it's cool. You can also take that asset. Like I said, I can take her and I could stick her into a Unity world, and then I could stick my fish into the Unity world, and I could build the fountain, and then I could have Ed animate the water because I'm no good at animating water. And then hopefully, once I've exported that and you're in like an Oculus Rift, you could walk around the fountain and like, you'd have this nice experience. Augmented reality, that maybe I could have like a fiducial here, you have your phone over it, and it brings up the 3D with the texture, right? Because clearly I didn't print these with texture. This is just straight up plastic. There are places like Shapeways where they can print now out of 50 different materials, which is really cool. Obviously metal and stuff is a little more expensive. They now have like carbon fiber options, and they embed color in a much more sophisticated way. We do have a color printer on campus. It uses inkjet color, and it's good, but it's not as good as Shapeways, but it's also a lot cheaper. And then again, 3D printing. So the Indianapolis School for the Blind and Visually Impaired, Jacob Ayers up there, he had done a drone flyover of the Benjamin Harrison house. And then he went in and he cleaned up and he printed a model of the house. So now these students can feel what the house looks like. And this is also really common for campuses. For the blind and visually impaired is you print out a campus. And so now explaining where this building is in relation to the GIS building, in relation to the track or assembly hall, that can now feel their way around campus. My other favorite example is the water bear or the tardigrade. This big? I don't know. It's very, very, very tiny. And you can print it out at like 5,000 times magnification. And so something I could only ever explain to this person, they can now feel. And then finally, geometric analysis. Like I said, you can have an understanding of something maybe on a level that you didn't have before. So the user communities, I think, right now scholars and researchers are on board, but they're still figuring it out. I think teachers and students, the more you can put some of these things in their hands. And then I think the general public, there is this wow factor. So we presented Tuck Langland, who's the person who did Ernie Pyle. On Ernie Pyle Day, he came, and we presented him with a 3D printout of the statue, and he was like, what? So we have a picture of him with the printout with the statue, which we thought was really cool. So, so I think there's a lot of ways to sort of get people excited about collections via these new avenues. So this is just really quickly, we've run about 919 jobs. I would say since then, we've run many more. We really need to update that slide. These are the kinds of jobs that we're running. The runtime in minutes, the median is 27. The number of requested nodes is about 4. Like I said, you could request 40, but because there's only a limited number of nodes, like I think there's only 76 of carbonate, like it's gonna be like, okay, you're pulling a really big bus into traffic. You're gonna have to wait for a huge space so that that bus has time to get up to speed. And the maximum number of photos, which is from the Monte Alban, was 14,261, which is awesome. And we hope to make it more someday. So we have these collections on Sketchfab. There are 3 different sets of Adam and Eves on campus. Don't ask me why. Someday I will know the answer to that. If I click on it, it should just flip out to it, correct? Oh. Yes. Did I say no? So let me pull it. Go to the corner, go to the corner. Huh, it's interesting that it's not giving me the, so we've made some of these private at the moment, but, so here's our hoagie. This is where Jeff can yell at me. So if you go 1.9 million polygons, that's too many, and it shouldn't be up there at that size. So I think we had a moment where we were like, but it'll take it, right? Like we were just staying under Sketchfab's recommended size, and just because it'll take it doesn't mean that it's a good idea. So it's saying, oh, you can spin this around. And there's the hole that, I mean, like, I don't know how I missed it for like 6 months. So this also is, we have a better version of this. You see, I had trouble with his hat. It's because it was really thin. So we do, and I thought we had linked to the better version. Okay. So Katie is checking that as we speak. Did a great job with the coat because that provides some differentiation along this smooth top of the piano, which is actually kind of hard for it. And then you can see down here is sort of the Google option. So we were really lucky on World Book Day. Thomas Flynn, who is the cultural heritage specialist at Sketchfab, chose the Book of Common Prayer with this art binding. And this is something, this is detail that you would not get from a scanner, where you could see these individual stitches. And actually, I do want to go. So you're like, well, this is a two-dimensional thing. Like, why do I want to do this? Oh, look, he put up lots of polygons too. Okay, so he's got points of interest here. And so this is cool because not all of us probably read Japanese, right? So it tells us about that. And then we can still sort of, we can go in closer or not. And then what he did is he went into Photoshop and he dimensionalized it. So you could 3D print it. And you can see just from looking here, so this is a really sort of quick and dirty dimensionalization that maybe doesn't take into account the fact that Mount Fuji is way, way in the background, right? If I turn it back around, and then there's layers sort of in front, like, you know, where does this boat go? Well, obviously this wave is in front of the boats behind that. So again, you probably want to play with this a little bit more. But I thought that was a really cool example of dimensionalization, which is something that we've just sort of waded into. Okay, so I feel like we have, oh, I'll say a little bit. This is the Uffizi digitization project. She's here because I spent a semester on her and I still love her. This is Niobid F3. She's actually not Psyche. There is one museum in Rome that has this like balloon-shaped wing set on her because she has holes in her back. They're from arrows because she's being shot by Artemis and Apollo. And they thought they were wing hole posts. It makes no sense. Like this is the only, so anyway, like, yeah. And other people have written papers, so I don't have to sort of, this is where though they've got the identifiers. Paradata, this is the only what I would call metadata. They have the camera, the photographer, the reconstruction software, and then the modeler. And I feel like that's not maybe enough, but we're sort of struggling right now with deciding what we're going to reveal on the Lily site. So this is an AVL flagship facility. We actually have some printouts of like different configurations of our new lab. They were able to scan this using the Matterport. You can navigate around it. They also printed out these different things to show at Supercomputing. Here is the Ruth Lilly Medical Library with a Matterport, and you can see what it looks like through your phone. So augmented reality apps. Here, there's a picture of the animal as it existed, and then when you hover over it with the fiducial is that picture, and when you hover over it, it gives you a jawbone that's in this collection. So there's Herman on his bench. There's Ernie. There's Hoagie before he like got broken. So you can see this is an Ultimaker and how it prints things. Some of that is water soluble plastic. So the white is all water soluble. And then you have to put him in a bath. And Herman, I'm contaminating him. His bath was too hot. So he needs to take another bath. So his bench is a little bit warped. So I have lots of conclusions, but really I'd rather sort of get to your questions. What? I'd rather get to your questions because I feel like we have lots and lots and lots of slides. How are we still going? God. Yeah, we need to cut this. Okay. So thank you. Yeah, clap for me. In my fever-induced state. Are there any questions online or in the room? Yeah. So you've got, so the question was, so you get done and you notice that his hat's really thin. What do you do? And so we had a discussion about this. You can extrude that using the software. One of the things like ZBrush or Mudbox is free. It's an Autodesk product, but it takes a hot minute. And so we decided, initially we were trying to also get the workflow down so that we didn't spend, we were trying to decide what a reasonable amount of time per object was. And as you get better at this, so each thing that you see on Bernie's site, I think it probably has 6 to 8 hours of post-processing cleanup done on it. So that's really a non-trivial amount of time. And I don't know that I'm against spending that amount of time.
What we like to do now, and we've been targeting, oh, sorry, nah, forget. So what we've been working on in the AVL to help Tassie as she goes out in the field is improve the workflows to where this doesn't happen. And we've actually got workflows that can capture a watertight mesh with no post-processing at all. I'd like to show Tyler's patina statue that he did. It'll give you an example where he did the full object, top and bottom, with good capture. And our argument is the same for scanning as it is for photogrammetry. The more time you spend up front making sure you're getting good photos will pay off down the pipeline a lot more later. Post-processing is expensive. It requires expertise. Taking good photos, you just have to get used to it, basically.
We have an online question. You mentioned creating models for those who are blind. Did you do anything with
I'll find it.
Could you repeat that question, please? I'm sorry.
You mentioned creating models for those who are blind. Did you do anything with touch graphics and or the Smithsonian on creating artifacts for everyone, not just those who are blind?
Yes. So recently the Ashkenazi approached us about a print collection that they have, but also possibly other things. So for teaching, basically having available, dimensionalizing some of these paintings like the Kanagawa waves, so that it would be an experience of that print in a completely different sort of haptic sense, right? So especially I think for younger students, and we even talked about blowing it up to like 200% if it's small. So these are details that you don't necessarily normally come in contact with. So I think there's a lot of ways in which touch is something that all of us can relate to. I know that I personally like really still want to feel a water bear. So like I think that's amazing. So I think there's a lot of ways in which there are people who specialize in educational outreach and the ways in which touch is used. We've also talked about the Lily has Lincoln's knuckles, like you've got his hand. And so they often, when the kids leave, they like do a fist bump on these bronze knuckles. But like how cool would it be if we printed some out for like classrooms that don't get to come to the Lily? And then like kids can go up and like fist bump the bronze, you know, whatever, if we make it out of steel, like the knuckle, and like be like, yeah, me and Lincoln, man, we're cool. So I mean like that you don't have to be a Bloomington area resident to sort of be afforded that opportunity. So, oh, the Andy Warhol Museum would be. We should look at like what they've done. That's really cool. What if we did like Andy Warhol in velvet? Like different napes of velvet for like different colors. Oh, cool. So this is a really also great example of like the different methods of capture and how they can compare to one another. And I was interested about the middle one and its color. Like, which do you think is the most color accurate? Oh, okay. Okay. So you can see the difference there between the scanner.
This object is about
and this really shows the limitations of the scanner. We had someone, Steve Vinson from Egyptology came to us, and he wanted to capture these tiny scarab beetles that are in the Ashkenazi. And at the time we were like, wow, like a scanning, they're too small. But if with something called focal stacking, you can capture them. Really? What? Oh, Pinky Demon. I thought you said patina.
Well, I showed that's on the other tab.
Oh, okay. Okay. I was like, wait, this tab?
Yep.
So you can.
But we just want to take more photos to mean what we think you need. And you can always get rid of them later, as opposed to having to go, crap, I go back out there and photograph the object.
Yeah.
What would be a really good suggestion for someone who just wants to friends for the first time? Like, what would be a good project? Like, what size object and where, what location would be? Would you rather take something internally, or sorry, inside and light it and then take it down, or go outside for different lighting?
Yeah, so outside has all kinds of, we used to have the major section that was like, if it's outside, so I've been wanting to go back and re-photograph parts of her, but it needs to be a cloudy day and not be freezing. But if it's not, if we wait too long there, you turn her back on, then I'm lost my opportunity till next fall. So I would say start inside. We do have, Polaroid makes these little light tents that are like $70. And they come with not like amazing lights, but that's how we started. And then we have a masking technique now, which is why we've been getting better results, where you create a mask that then gets rid of everything that's not the object. And so it makes stitching much easier. So yeah, I would start, and then I think Matt's first project was a pair of his old track spikes from high school. So track spikes. Yeah, so shoes, sorry. So, you know, so we were sort of thinking about like if we did do a project with athletics or whatever that, yeah. Yeah, I was gonna say, we have a loan out to Melanie Pennington right now of, I do have a kit that has the camera like I brought over. And actually, so we only have one sort of fancy lighting system, but we could bring the tripod and the bigger tent over and then let you and Bill and whatever just like have at it for a while. And I told Bill, you know, I think the one thing you don't need maybe is the camera, but we're happy to lend you our camera too.
Lighting kit, the tripod, and a green screen. That's what I was thinking of, just trying to look at. But I didn't know.
So you can do green screen. What we noticed sometimes was that the green reflects onto the object. Yeah, so one of the things the Smithsonian does that's actually really interesting is they often photograph on black velvet or black cloth, and then they go into Photoshop and they basically flatten out the black background so it completely disappears. And I don't know anybody else who's doing it that way. But yeah, initially I went and got some really bright colored backgrounds to try and make the masking easier. And then they had like, yeah, that hue on it. So.
So could you say something about the workflow that was designed for a project where you wanted to capture some real thing, modify it, and then 3D print it? I'll tell you where this is coming from.
Yeah.
I'm in electronic music. I have a new colleague coming who's all about performing on instruments that she builds.
Ooh.
Censored instruments, and I'm imagining she might enjoy a project where there was some object that seemed like a good idea, but you need to modify it and something to it. So what's the basic workflow? You mentioned watertight also.
Yes. Yeah, you do. Yeah, you do.
So the closest real world example that applies to what you're doing is exactly what Melanie Pennington's doing. She's got sculptor students and they're sculpting these humanimal objects that Tassie described. And then they're bringing it into Autodesk Mesh Mixer, another free software package, healing the mesh to where it is watertight. And I've given her workflows on how to do that. She was not digital. She's doing it mostly on her own now. And then she's 3D printing. They might modify them. They can do that in Mesh Mixer, like sculpt it more or differently. And then they're 3D printing those as well. That's the closest example to what you're describing. The one gotcha I'm hearing in your workflow, these instruments sound like they could be keyboards or they could be.
No, anything that you could strap some kind of sensors on.
Oh, okay. All right. So it could be an organic shape. Okay, all right, then yeah, this workflow would apply. And when we say workflows, we have these documented, I believe, in pay by numbers, big pictures. They're long. Don't let that intimidate you. Some of them are like 100 pages, but it's a lot, literally, because we're doing step by step. It's like,
right, so we can
we're
share
like
that
click.
document
Yeah.
with you as well. And then also we can come the first time if you want. So these are these food animals.
Yeah.
My friend's not in here. No, this crow person was just amazing.
Tassie briefly mentioned it just now. We do initial consults. Oh, sorry. Tassie mentioned it just a second ago. We do initial consults for a lot of the things you're asking. Either you come to us, it depends on the collection. Either you come to us or we'll go to you. Melanie's case, we have to go to her classroom, teach her how to use the equipment, and then we're tier 2 support. And that's how we would treat most of these situations.
Yeah, I could see how like, so I've done a little bit with like sort of embroidery and like those kinds of things, right? So I was at a conference where we were given, everyone else got a line of poetry and then they were asked to program their lily pad. I got a line of literary criticism and I was like, okay, yeah, I mean, that's what my PhD is in, but still, like, I feel like I got the hardest thing. But it was also racial literary criticism. So it was about Black and white people and like the sound of like, and so I put this background noise that was the white people because we're always talking, right? And then I had like the song was sort of the Black folks sort of rising up above the, and that was as much as I was capable of at the moment. But I was very proud of my, yeah, my non-poetical interpretation of it. But yeah, so so it sounds like what she's doing is really cool. What they do is they take these into, so Rhino is a modeling thing. Nicole Jacquard on campus also uses that. And then she will take the jewelry that she creates and then sort of morph it in Rhino, but then make sure it meets the needs for 3D printing and then get it printed out. So
I've seen 3D printed objects that have like lattice work.
yeah.
So, and that's still watertight? More specific kind of description.
Right, so it's not that like it can literally hold water, it's that structure is a line that doesn't have holes in it. Yes, exactly, because if you think about it, like this doesn't hold water, but this, right, is connected and has and even here we could have separated like his little box, but yeah.
It's a term we should probably clarify. It means water could not escape.
Oh,
From inside
I've never had.
continuous.
Mind blown. Any other questions? So yeah, please feel free to get in touch with us, cyberdh@iu.edu, vishelp@iu.edu. We're happy to be here and share documents, and I'm actually talking to Ryan soon, so yeah. Okay.